Everyone, welcome to the another very important session in which we will be discussing some more important questions and very important concepts for our upcoming CSIR net and the GATE physics exam. So guys, we will be starting the discussion about these questions and the concepts soon in this session. But before that, I need to show you some of the important slides. So let me just show you some of the important slides and we will be starting the discussion after that. So guys, if in case you will be having any doubt or difficulty in understanding any of the concepts at any point of time, you can surely let me know about it and we will try to consider those points then. And if everything will keep on getting clear to you, then that's great. So let's start the discussion. Let me just start showing you some important slides, and after that let's continue the discussion about the important concepts and the points which we will be considering today in this session. So actually guys, the first slide you can see right now is regarding the Unacademy learning app, and the another one is about the session, then something about me, and then something about the Unacademy learning app's community feature. Okay, now next we are gonna have is the information about the Unacademy iconic subscription, which will surely be helping you to do the best preparation under the guidance of top educators. Even now the important notes are available on the learning app, which will be helping you to do the best preparation under the guidance of top educators and with the well structured and well planned courses by the top educators. So all this will be surely helping you a lot to take your preparation to the next level under the guidance of top educators. And guys, whenever you will be taking the subscription, you can use and apply the code that is Anjali A Live as mentioned here on the screen. So by using and by applying this code, you will be able to get the discount in the total subscription amount. Even for the plus subscription, we will be having the notes available on the learning app, which will surely be helping you to take your preparation to the next level. Also guys, if I'm going to talk about the next important thing, this is about the light subscription, and this slide is going to make it clear to you what is the difference between the plus iconic and the light subscription. Also guys, as you can see, the referral code has been mentioned here on the screen. So by using and by applying this code, you will be able to get the discount in the total subscription amount. Very good evening Anjana, very good evening Sakshi. And guys, now we are ready to start the discussion about the important concepts of the atomic and molecular physics. So what I will do, I'm going to take the different questions here, and along with that I'll be discussing the important concepts too. Okay, so that's what we will be doing now. And anywhere if you will be having any doubt, make sure you are going to mention it in the comments and I'll just try to consider it as well. Again, the questions will be from different topics, concepts and the points. So I will be helping you to understand that which particular concept needs to be used at what point and how you will be solving that particular question, what will be the best way to solve it. Also guys, in upcoming days, many new courses by the top educators will also be starting on Unacademy. So in that case, if you're the one like who is going to have difficulty in like at any point of time with these courses and classes by the top educators, you can even take your preparation to the next level. And as you know, whenever you will be taking the subscription, you can use and apply the code that is Anjali A Live, as I have just now shown you. It's here. So it's same as it is, you just have to note it down, and by using and by applying this code, you will be able to get the discount in the total subscription amount. Let me just write the first question now and let's talk about the concept too. I'm just going to write it. the number of permitted transitions from 2p 3 by 2 to 2s 1 by 2 in the presence of a weak magnetic field. This is the main point of a weak magnetic. Very good evening, Komal. Field is what? It's 4. Is it 5? Or is this going to be 6? Or is this going to be 10? So if you think you can solve it and you know the process to solve it, I will be giving you some time to work on it, guys. Otherwise, just in some time, I will be starting the discussion and I will let you know that what will be the best approach to work on this question and how you should solve it. Very good evening, Mutyam. Anjana, okay, I can read it for you. So the number of permitted transitions from 2p 3 by 2 to 2s 1 by 2 in the presence of a weak magnetic field is. Still, if you are not getting it, you can tell me. I can read it again. And guys, try to solve it. Otherwise, I'm gonna start telling you what will be the best approach to write it, to work on it. The number of permitted transitions from 2p 3 by 2 to 2s 1 by 2 in the presence of weak magnetic field. So when you get the term weak magnetic field, it is providing you the hint, okay? That's going to be, okay, very good, Sakshi, that's correct. So in this case, you are getting to know that it is the G-man effect based question, right? And when you are going to get to know about it, that it is the G-man effect based question. Now for the number of permitted transitions, there is a formula you need to consider. What is that? That is 4J1 plus 2J2 plus 1. So J1 will be what? Here J1 will be less than J2 always. But if let's say J values are same in any case, then any value you can put. But if there is a difference in the J values, one is smaller, another one is greater, then your J1 you have to select in such a way that J1 should be smaller than J2. Also, one more thing, guys, that you should know about the spectroscopic term notation, which is 2s plus 1 Lj. So here this is representing J and this is representing J, right? So which one is the smaller? That is 1 over 2. So it will give you 4 times 1 over 2 plus 2 times 3 over 2, which is the larger value. So with the smaller number, which is 2, you are multiplying the larger value. And with the larger number, which is 4, you are multiplying the smaller value, right? For J. And plus 1. So 2 to the 4, 2 ones are 2, 3 to 5 and 1 6. So you got the final answer to be 6. This is how you are going to get option C to be correct option. Please tell me if in case still there is any doubt anybody is going to have. And if everything is clear, then that's great. Very good, Deepika. That's great. Komal, what's the time right now? I think it's above 9, right? Is it? Yeah, 9:24 approx. Yep, I can understand it. So you can have your dinner along with the session if you want. Okay, guys, can I take the next question if it is clear to everyone? Ready? For the next one, let's take the next question then. It's here. The number of, very good, Pravalika, the number of spectral lines allowed. I think for this one now everybody will be able to get the answer. Okay, but let's see how many of you will give the right answer for this. The number of spectral lines allowed in the spectrum for the three to D to 3 to B transition in sodium is. Transition in sodium is, options are 10, 12, 16, or is it going to be 28? Now let's see how many of you will be getting the right answer for this one. If there will be any difficulty anybody will have, I will be talking about it then, don't worry. But if you think you can get the answer for this one, then that's great, guys. You can start working on it. Let me know what is the right answer according to you. Waiting for your reply, guys. Otherwise, I'm gonna start the discussion soon. Very good, Pravalika. Very good, Komal. Very good, Anjana. But guys, I'll be telling you whether it is right or not in just some time. Let's wait for others' reply as well. Okay. So 3 students have answered till now, guys. If you are even gonna get the answer, you can just mention it. Otherwise, I'm gonna let you know that what is the final correct answer. Just for a few more seconds, we are gonna wait. Okay, my question to you is to start the discussion about the answer. Did they give you the J values this time? Did they give you the J values this time? In the spectroscopic term notation, which is 2s plus 1 Lj. Do you have the J value given to you? The answer is no, they didn't mention the J value. Because we know that this is the spectroscopic term, right? So J is not given. That means we have to find J, right? So in that case, what is the process to find J? In my recent session, that was a special session, a free live class for everyone. I had it yesterday. So in that case, I have talked about everything about the spectroscopic terms. If you have joined it, you will be familiar with it. If you didn't, you can check out the recordings later on. But something about it, I will tell you even now. So Here 2s plus 1 value is what? 2. Okay, even in the previous question I have written this spectroscopic term notation. And here also 2s plus 1 value is 2. So in both cases it is 2. I can get the spin from there. So that is spin will be 1 over 2, right? And the L value for the d orbital will be what? SPD 0, 1, 2, right? And for the p orbital, that is going to be SP 0, 1. So in this case, what will happen? J is equal to L minus S to L plus S. Everybody knows about that, right? So in this case, what will happen? It's going to give you the L is what? 2 for the first case. And S is what? 1 over 2. So L minus S is what? 2 minus 1 over 2, that is 3 by 2. And L plus S will be what? That is 2 plus 1 over 2, which is 5 by 2. So 3 by 2 and 5 by 2. Now second case. The 2s plus 1 again here is 2, which will give me the spin 1 over 2, but its L value is 1. So in that case, I will have the J values as L minus S to L plus S, which is 1 minus half to 1 plus half, which is 1 over 2 and 3 by 2. Now, since they are talking about what? Again, the G-man effect. So are you familiar with the selection rule of G-man effect, which is going to let you know that how the transitions can take place, means what can be the difference in the J values for the transition to take place. So if I'm going to talk about these two possibilities, 3 by 2 and 5 by 2 in one case, and another case we are going to have is 1 over 2 and 3 by 2, right? 1 over 2 and 3 over 2. So the difference between 3 over 2 and 1 over 2 is of one value, right? So is this transition possible? Is this combination of J values possible as per the G-man effect? Can anybody let me know? So can you have a transition taking place in case of G-man effect when there is going to be a gap or a difference of one value between the two J values, like here? Done? And other case, like yes, it is allowed. If you are not familiar with it, I'm going to tell you delta J can be equal to plus minus 1. Or can delta J be 0? So yes, it can be 0. But can it be 2? So answer is no, it cannot be 2. So that means the possible combinations I can have is 5 by 2 to 3 by 2, 3 by 2 to 1 by 2, and 3 by 2 to 3 by 2 transition is also possible. So which one is not possible? 5 by 2 to 1 by 2 transition is not possible. Reason behind it, 5 by 2 minus 1 by 2 is 2. And that transition cannot take place between the two states having the difference in the values. That's going to be 2. Okay, that's what you have to consider. Now, let me know about the next thing here. What is that? That's going to be, see, if we are going to talk about the next particular case, so we have to get the total number of transitions possible when the transition is taking place from 3 by 2 to 1 by 2. So it will be 4 times the smaller J value plus 2 times the larger J value, okay, plus 1. Then here 4 times 3 by 2, because this time it's gonna be equal. Yep. And spectral lines, so that's what we are going to talk about. 4 times 3 by 2 plus 2 times 3 by 2 plus 1, right? And here you will have 4 times 3 by 2 plus 2 times 5 by 2 and then plus 1. So that's what you are going to have, right? So find the total number of transitions in this case, or spectral lines in this case, for that particular transition between 3 by 2 and 1 by 2. So it is going to be 2 plus 3 plus 1, 3, 2, 5 and 1, 6. And in this case, 2 to the 4, 3 to the 6 plus 5, 11 and 1, 12. And then 2 to the 4, 3 to the 6, 6 and 3, 9 and 1, 10. So 10 plus 12, 22, 22 plus 6, 28. So that's going to be option D, which is the correct option we are going to have. Okay, can you see this? Number of spectral lines allowed in the spectrum for this transition in sodium is. So the answer will be 28. Pravalika, is that clear? And to everyone, is this clear? So these are total number of spectral lines you are going to have. And since 5/2 to 1/2 transition was not possible, we didn't include it then. Okay guys, let me know if in case still anybody is having any doubt. So this question was also based on the G-min effect and how to find the total number of spectral lines and all. So based on first concept, but a little bit modification was there. Here we have to find J values and we have to decide how many transitions will be possible. Okay, so that's how you are gonna get it. Anjana, it's going to be 28, and everybody can have a look at this part and tell me still if there is doubt. 10, 12 and 6, add them, it's 28. Can I give you the next question if it is clear? If in this one anybody is having doubt, let me know. Done? Next one is also quite interesting. Let's do this. The spacing between LCM for what, Anjana? It is not the LCM we have found. We have used the formula 4J1 plus 2J2 plus 1. When the values of J1 and J2 are different, then the smaller value will be taken as J1. Okay, and that's what we have found out for all the transitions which are allowed and possible. So we got these values and we are just adding them. Yeah. Anjana, can you hear me? Done? Guys, can you hear me? Let me just check. Okay, I think it's audible and everything is fine. So let's go over the next one. And if it's still, Anjana, you are gonna have any doubt, just mention it. I'll talk about that. While there was nothing like LCM, we just found out the value for the number of possible spectral lines, and then we are gonna just add the total values. Now here is the next question for you guys. The spacing between vibrational energy levels in carbon monoxide, that is CO molecule, is found to be 8.44 times 10 to the power negative 2 electron volts, given that the reduced mass of carbon monoxide is 1.14 times 10 to the power negative 26 kgs. Also guys, one thing about the atomic and molecular physics I want to mention here, because there will be some of the students like those who have not started the preparation about it till now, okay, those who have not studied it earlier so much, and they're not familiar with this subject too much, right, in terms of doing preparation for the NET exam. So let me just tell you, its syllabus is quite less in comparison to other subjects. Okay, other than that, there are few topics like you can just finalize that initially you want to prepare these topics, and in very less time you can cover up this subject. Okay, means in terms of doing the preparation of what you can have the great chances for you to have in the exam. Okay, the topics. So make the list of those topics and try to cover them up. It's that much less that within a week you can have a better command on this subject and whatever you can expect in the exam. So if you're the one who is planning to do the preparation, you can keep it as like the priority one, the priority subject to cover up and complete, not as a first one, because first I always suggest you to go for mathematical physics, because in different subjects, while classical, quantum, or condensed matter, or in different subjects, you need many things which you prepare in mathematical physics. Like if somebody is there who is not having a good command in differential equation, somebody is there who is not having good command in a particular mathematical calculation, so when you go for mathematical physics as your first subject, you are able to recall, revise so many mathematical formulas, and along with that you have a better command on them, whatever you need to use while solving the other subject questions too. So I think that is somewhere helpful to work on other subjects as well. But after that or along with that, you can plan to cover up your atomic and molecular physics as a subject too for your exam, and this is how you can keep on completing your different subjects for the exam. That will surely make you feel more confident and will help you to cover up the things one by one for the exam. So next thing is Planck's constant, and even if you want me to mention the topics you should target to complete from this subject, first of all, we can discuss that as well. 26 times 10 to the power negative 34 joule seconds, and 1 electron volt value is also given to you in joules, which is 1.6 times 10 to the power negative 19 joules. Other than that, the force constant of the bond in carbon monoxide molecule is, I'm writing the options here so that everything will be on one single slide, and anybody if wants to look at the options can have a look at that at the same time when somebody will be observing the question. 18.7 Newton per meter, 187, 1870, 1870. Try it now, guys, and let me know if you are gonna get the final answer. If you will not get it, I'm surely gonna help you with the process and the steps you have to take. But if you will be able to get it, then that's great. Tell me what will be the right answer, and can you relate the formula you have to use? Very good, Pravalika. That's great. Very good, Anjana. That's great. Very good, everyone. Yeah. What about others, guys? If you're not gonna get it, I'll be helping you in that case. So basically, if you will read this question, you are gonna get like, okay, it's related to vibrational spectra part, okay? Other than that, they have given you what? They have given you the spacing between the energy levels, means the energy difference, that is delta E. Spacing between the energy levels. Spacing means what? The difference, right? Very good, Sakshi, that's great. And given that the reduced mass, which means it's mu given to you, okay? And now Planck's constant is even given, and the conversion is also given here. Now we have to get the force constant, right? So you need to know one thing, that in case of vibrational spectra, the energy is, like you know about the harmonic oscillator. So here we are going to write it as n plus half h nu, okay? Now, in this case, the nu is also going to have the value which is 1 over 2 pi root k by mu. And mu is the reduced mass, but k is what? K is going to be here our force constant which we need to find. So if you will see the energy difference between the two levels, okay, this is the spacing between vibrational energy levels and CO molecule is found to be this. So when you will consider n is equal to 0 and n is equal to 1, the energy difference for E1 minus E0 will be just h nu, which means this value which you had here is nothing but the h nu value, because that is the energy difference, right? Now once you got to know about that, what next? The next thing is you just simply need to equate it with h nu, or you can plug in the value of nu at this place and get the value of k from there. This is what you have to do. And you can see your final units should be Newton per meter. So accordingly, if you think you have to plug in any value or you have to do some conversion to get the final answer in Newton per meter, you can just simply do that. Done? Let me know if in case there is anybody having any doubt. So in this equation, you're just going to plug in the h nu. E1 minus E0 is already given to you in the question, which is 8.44 times 10 to the power negative 2 electron volts. Planck's constant h is also given to you. You just have to plug in this value there. And new value you will plug in. Reduced mass is also given to you. 2 pi the constant, you already know that. And once you're going to do all this, you will be getting your final answer. The conversion in joule second you can do when you will be working on the answer steps. So 1 electron volt is these many joule seconds. You can do that conversion too. Okay, and this calculation will give you the answer 187 Newton per meter. You can tell me if in case there is any doubt anybody is gonna have even now. So just multiply this energy with the 1.6 times 10 to the power negative 19 to convert it into joules. Anybody is still having any doubt? If yes, let me know. And if no, I'll give you the next question then. Tell me if you are ready to work on the next question. Or is there any doubt you're gonna have now? Once done, mention done guys, then only I'll give you the next question. And if you are having confusion in terms of taking the steps to solve it, or you are not getting any steps, you can just ask that and I'll be making it clear to you. Tell me. Is it clear? And everybody is getting the answer? That's option C, 187 Newton per meter. Waiting for your reply, guys. Next question is waiting for you too. But once everybody is going to give the confirmation, I'm going to give you the next question. Are you ready? Are you ready? Are you ready? Is there any doubt? If yes, just mention your doubt. And if no, here's the next question for you. There are 4 electrons in the 3D shell of an isolated atom. The total magnetic moment, that's great guys. The total magnetic moment of the atom in units of Bohr magneton is. Options are 0, 1, 2, 3. What is the answer? Bohr magneton, like based on the magnetic moment part, like it's important. Done. Just how to write the answer in terms of Bohr magneton, as well as what is the formula for the total magnetic moment. That's very important. So if there is someone like who doesn't know about it, what is the formula for the magnetic moment, you are gonna learn that right now, and that will be helping you at so many different places. So the best thing is, when you are working on the questions, when you are doing something and you learn from that part, right? Even the small things you learn and you use it at different places while working on different questions, different concepts you learn, and you relate that point there. So it makes the learning easy, as well as you can get so many things this way. Waiting for everyone's reply, or otherwise I'll be starting the discussion soon. There are 4 electrons in the 3D shell of an isolated atom. The total magnetic moment of the atom in units of Bohr magneton will be what? Should I start the discussion? Very good, Pravalika. That's great. What about others, guys? Only one answer is there. Okay, Sakshi, waiting for your reply. Those who don't know the formula for the magnetic moment, guys, it's going to be mu is equal to negative G. G is gonna tell you about the Lambda G factor, okay, and then E over 2m and vector J. Vector J means root J into J plus 1 h cut. Very good, Anjana, that's great. Okay, and J is square root J into J plus 1 h cut. That's its value. So in this case, if you are gonna consider, very good Sakshi, that's great. There are 4 electrons in the d orbital, right? Then in that case, the total magnetic moment you want to find. So 4 electrons in the d orbital, if I want to find its ground state, then I will be following this process, which is quite simple and easy to follow. And for d orbital, you can have total 10 electrons, right? So that means 5 partitions will be there, because opposite spin 2 electrons you can have in each state. So 1, 2, 3, 4 electrons. This way you will locate. Plus 2, plus 1, 0, minus 1, minus 2. This is what you can have. This is for ml. Summation ml is equal to what? Plus 2, plus 1, plus 0, minus 1. This is what you will find first of all, and this value which you got, you will treat it as just L. Same way, ms, that is magnetic spin quantum number, will be plus 1 over 2, plus 1 over 2, plus 1 over 2, plus 1 over 2, which is 4 over 2, which is 2 itself. So summation ms is equal to 2 as well, which is your s value. So J is equal to L minus S to L plus S, which will give you 0, 1, 2, 3 and 4. Once you got it, what next you have to do? The next thing is you had the D4, which belongs to the less than half filled category. So smallest J value or the lowest J value will have the lowest energy, which means the ground state energy. So your J value corresponding to the ground state will be J is equal to 0. And that's how, when you will just plug in the magnitude of vector J, which is root J into J plus 1 h cut. So when you will plug in J is equal to 0 here, that will give you the overall magnetic moment 0, and that's how your option A is correct. Now, how many things you can learn from this question? One is the magnetic moment formula. The another one is going to be how to work on finding the ground state J, L or S values for the spectroscopic term in particular case. That's what you learn from this question, and that can help you to work on so many different questions too. Please tell me, is it okay and clear to everyone now? And still, if there is any doubt, you can surely mention it and let me know about it. We can talk about that part, but if it is clear, we are ready to consider the next question. Quite simple and easy. The next one is not difficult. Is it clear? Can I give you the next one then? Are you ready? Okay, great. It's here. The first is Stokes line of a rotational Raman spectrum is observed at 12.96 centimeter inverse, considering the rigid rotor approximation the rotational constant is given by that's great, guys. Options are 6.48 centimeter inverse. Next one is 3.24 centimeter inverse. Next one is 2.16 centimeter inverse. Next one is 1.62 centimeter inverse. Waiting for your reply. If you don't know what to do, I will let you know then. But if you know, I will wait for your answer. What is the right answer according to you guys? Very good, Sakshi. But I'm gonna make it clear just in some time what is the right option, okay? Till then, very good for everyone who will be getting some answer. Okay, guys, what about others? See, there should be like kind of happiness you should have when you are practicing the questions, and even if in case any answer you get and it's not correct. Should we be happy or should we be quite not so happy? I think we should be happy. Why? Because this is the time you are learning, right? If you had a concept which was wrong and you think it is right, so before your exam and at this point of time, if you're gonna get to know, no, actually it's wrong, it's not the correct concept. So in that case, what will happen? You are getting a chance to improve, you are getting a chance to learn, right? And that's the point of happiness, that oh, before the exam I made improvement, I learned that oh, what I was thinking is correct is actually not correct, right? So that's gonna be the point. We should be happy that we got a chance to learn. And if you already know something, then also you should be happy. Why? Because you have already done efforts to learn it and you know what is right. So both have their pros and cons. What about others? Just one answer is there till now, guys. While I was expecting like everybody is gonna answer for this question so quickly. Okay, done. Right, Sakshi? That we were thinking it's correct, but that was incorrect. So I made that mistake at that point of time. Now I need to be extra careful that I'm not repeating the same mistake and I'm gonna improve. So every time we can recall like, oh, last time I did this mistake, now I have to be careful. Right? Yeah, that's correct. Very good, Deepika. Very good, everyone. Very good, everyone. Still waiting for more reply. 2 answers are there. Sakshi and Deepika have answered. What about others? What about others? What about others? Okay, before answering this question, until the time you guys are trying to answer it, I'm just going to talk about the concept. Very good, Pramalika. Okay, guys. So there is Raman spectrum. Okay. In case of Raman spectrum, we are going to have 3 lines basically we will draw. One is Rayleigh line, which is also known as exciting line. Other side we will have the Stokes line. Stokes, Rayleigh, anti-Stokes, right? So from the Rayleigh line to the first Stokes line, the wave number separation is 6b. Rayleigh line to first anti-Stokes line, the wave number separation is 6b. First Stokes line to second Stokes line, the wave number separation is 4b. First anti-Stokes line to second anti-Stokes line, the wave number separation is 4b. My question is, first Stokes line to second anti-Stokes line, what is the total wave number separation? First Stokes to second anti-Stokes line, total separation. First Stokes, second anti-Stokes. Total separation, answer in the comments. First Stokes to second anti-Stokes. Repeating it so that you will not get confused. First Stokes to second anti-Stokes, the total separation. First Stokes to second anti-Stokes. 6, 6, 12, 12 for 10 or 12 for 16, right? 16B, first stock to second anti-stock. Everything is clear now. But relay to first second anti-stock, this separation is 10B. Okay, done. Now let's go back to the question. The first Stokes line of a rotational Raman spectrum is observed at this centimeter inverse is telling you the wave number. So first Stokes line will be at what separation from the Rayleigh line? They just give you the with respect to the Rayleigh line. So what is the separation to first Stokes line? 6B. That means they are saying this value is equal to 6 times the B. B is the rotational constant there. Considering the rigid rotor approximation, the rotational constant is given by the B value will be what? 6 2s are 12, 6 1s are 6, 6 are 36. So I'm getting 2.16. What is the right answer now? Very good, Sakshi. That's great. What about others, guys? Everybody is getting it or no? Please let me know. If you are getting it now, you can solve any question based on the rotational spectra. Raman spectra. Okay. So that's going to be clear to you. Even I have more questions from this concept. So I will try to give you now after this. And you will be getting the right answer. Very good, Deepika. That's great. And guys, if you learned this part, what I have explained just now here, it's going to help you a lot to work on any such type of question. Can you see one more thing? I have made the Rayleigh line quite large. Stokes line is smaller than that. And anti-stock, I tried to make it more small, but it is not looking like much more smaller than anti-stock. But now you can see it's a small, right? So that is even the point, which is very important and will be helping you at different places too. Pravalika, are you getting 14 now? 14 for what? 16. Okay, I think you were answering for this. Right. That's correct. Done? Can I give you the next question, guys? Are you ready for the next one? Should I give you the next question? And this concept is very important. If you have got it correct, you will be able to. And the larger, smaller values which I have just shown you, that is even important. Let me just give you the next question then. I want to take the similar concept based question, so that's why I'm going to take some time, but I'll be taking that one. Okay, here it is. Well, I've given you some hint to answer it, but let's see how many of you got that hint. In a spectrum, while the question next time when they will ask in the exam, they can modify it. Means they can give you the values instead of just the notations. They can give you that, okay, this is this value, this is this value. Now tell me which one out of ABC is representing Rayleigh, which one out of ABC is representing stocks, which one out of these is representing anti-stock. So all that you will be able to answer if you know these things which we are talking about right now. So in a spectrum resulting from Raman scattering, let IR denote the intensity of Rayleigh scattering and IS and IAS denote the most intense stocks line and the most intense anti-stocks line. Respectively. The correct order of these intensities is options are IS is greater than IR is greater than IAS. B. IR is greater than IS is greater than IAS. C. Option says AS, R, S. D. Option says R, AS, S. Tell me if something is not clear. You can tell me. I'll read that option again. But if you are getting it, you can tell me what is the right answer. Still, if you will not get it, you are going to learn that. I'll tell you then. Try. Very good, Sakshi. That's great. What about others? What do you think is the right answer, guys? If you have got the point I mentioned there, it's larger, smaller, you got it. Very good, Deepika. That's great. Okay, so based on this, I think similar question we had either in net and gate both, okay, or twice in net. So it has been asked again and again. So that's what I was saying, like in upcoming exams even they can ask you, but what they can do, instead of giving you just the notations for the stocks, anti-stocks and relay as IS, IR, IAS, they can give you A, B, C, and they can give you, okay, this is the value for intensity, this is the value of intensity, and this is the value of intensity. Now tell me which one is showing the relay. So you will say whichever is the largest intensity one, it's relay, right? So that question can be answered with this concept too. Means any kind of modification, but when you know which one will be largest, which one will be the smallest, you're ready to answer it. So write sequences as given in option B, and that is your correct answer. If still there is anybody having any doubt, just let me know. I'll talk about it. But if it is clear, I am gonna give you the next question. Again, something related to what you learned today. And I hope you will be able to get its answer too. But let me just give you the question first. And if anybody is having any question, query or doubt, just let me know. I will try to answer it, guys. Let me just give you the next question as well. Which one I want to give you is... It's here, guys. It's here. Our question is here. Are you ready? Are you ready? It's here. Okay, very good, Pravalika. That's correct. So next question is the energy levels corresponding to the rotational motion of a molecule are E day is equal to B day times day plus 1 centimeter inverse, and where J is equal to 1012. Also, one more thing, if somebody is there who doesn't know what is the rotational energy formula, this is the rotational energy formula. B is the rotational constant here. And what are the values, allowed values of J? Okay, rotational quantum number. They start from 0. Many students are going to have the confusion that from where J values start. So from 0, not from 1. Okay, the formula you can learn, J values you can focus on. Okay, it's something exactly same as what they are in the main topic. Next one. And B is a constant. Pure rotational Raman transitions follow the selection rule delta J is equal to 0 comma plus minus 2. When the molecule is irradiated, the separation between the closest Stokes and anti-Stokes lines is options are 6B. See, all questions I am giving you right now are from the previous years, either from NET or from GATE. But mostly I have taken from NET now, and earlier I think few were from GATE too. So if anybody is there like who is preparing for any of these exams or even for any other similar exams, the details and the discussion we are doing here will be surely helping you. Okay, so it's exactly related to what you can expect and what you get in the exams. Okay guys, here is the question. If anybody is getting the answer, just mention it. What is the right answer according to you? If you will have doubt or difficulty, let me know. I'll talk about it. Oh, I think most of you have already answered. Very good, Sakshi. Very good, Deepika. Very good, Pravalika. That's great, guys. So, as you already know now that what is the sequence and what is the difference in terms of wave number. So, this is Rayleigh. This is first stocks. This is first anti-stock. So, stock, anti-stock. 6B separation, 6B separation. So, they have asked closed stocks and anti-stocks. Means between first. So that is 12B. We got the answer. That's option B. Okay, this is how you can just get it. Tell me still if there is anybody having any doubt. We will be talking about it then. But if everything is getting clear to everyone, then that's great. We are ready to take the next question. Anybody is there having any doubt? If yes, you can just mention it. And this was from June 2019, the question I have given you just now. And the previous one, I think, was from, let me just tell you, was from December 19. Hello, Rani. Sakshi, yes, there is one more session after this, which is about condensed matter physics. So today we are going to have 2 sessions. If anytime anybody will be missing the session, guys, then they can have a look at the recordings if in case you are not able to attend the live. Well, I would suggest you to join the live session, because then at the same time you can ask your doubt. At the same time, if you are not getting something, you can just ask about it. So I think that can make the things more clear, and you get the opportunity to ask your doubts and to make them clear as well. Deepika, few more minutes. Okay, guys, let's take this one now. It's for a few more minutes, approximately till 15-20 minutes more we can have the session. Then after this one, we will start the next one. The absorption lines arising from, Rani, which question you want me to explain again? Please tell me. The absorption lines arising from pure rotational effects of HCl are observed at 83.03 centimeter inverse, 103.73 centimeter inverse, 124.30 centimeter inverse, 145.03 centimeter inverse, and 165.51 centimeter inverse. The moment of inertia Oh, okay. I think you have recently joined the session, so you missed that previous discussion, because not just now, before this also we have talked about it in this session itself. So quickly we just talked about it right here. Okay, because that discussion was done, but I'm going to explain you and tell me if you are going to get it or no. So in the Raman spectra, we are going to get 3 different lines. One is Rayleigh line, another one is the Stokes line, and the other one is anti-Stock line. Okay. Now the separation in terms of wave number between the Rayleigh line and the first Stock line is going to be 6B, where B is the rotational constant. Also the separation between the Rayleigh to the first anti-Stock line is also what? That's 6B. But at the same time, the separation between the first Stock and second Stock line is what? 4B. And further the separation keeps on going like 4B, 4B, 4B. And then here also the separation between first anti-stock and second anti-stock line is also what? 4B. Other than the first separation from relay to the first stock line and relay to the first anti-stock line, that's simply 6B. So your question has asked you to find the separation between the last line, the separation between the closest stocks and anti-stocks lines will be what in centimeter inverse. So you know closest stock and closest anti-stock line are these ones. So total separation is what? 6B plus 6B, that is 12B. So your answer will be 12B, which is option B. That will be the correct answer. While the further separations between first stock, second stock line, that's 4B, first anti-stock, second anti-stock line, that's 4B. So further separations are just 4B. You need to know that for solving any such question. If they anytime ask you what is the separation between first stock and second stock line, 4B. Second stock and third stock line, 4B. Okay, or anything they just modify, you will be able to answer it. Rani, is it clear now? Done? If yes, that's great. But if there is any doubt, you can just let me know. Clear? Clear, clear, clear. If yes, we can go for the next question. If there is doubt, just mention it. I'll take or consider that doubt too. The moment of inertia of the HCl molecule, that's great, is also they have given you the value here, guys. Take h cut over 2 pi c is equal to 5.6 times. I'll be writing that value here. You may not be able to read it at that corner. 10 to the power negative 44 kg meter. And the options are 1.1 times 10 to the power negative 48 kilogram meter square. Also, guys, in the early morning timings also we can have the session. So as you got to know about this one, you will also be getting the information about that if it will be there anytime. 2.8 times 10 to the power negative 47. While after this today, at this point of time, we will have one more session. Kilogram meter square. And next we are going to have is 2.8 times 10 to the power negative 48 kilogram meter square. If something is not clear, I can read it again. You can tell me. 1.1 times 10 to the power negative 42 kilogram meter square. Tell me if in case there is any doubt. So the absorption lines arising from pure rotational effects of HCl are observed at this, and this. Okay, wave number values have been given. The moment of inertia of the HCl molecule is what? Is there anyone who can tell me like what is the concept you will include here while solving it, and what is in your mind like, okay, this can help me? Anybody wants to mention something? I'm gonna wait for your reply, or otherwise I'm gonna mention it what I wanted to hear from you and what will be helping you here as well. Okay, so they are talking about absorption spectra right now. We study about it when we talk about rotational spectra part. Okay, there are two main topics of atomic and molecular physics which everybody needs to prepare. One is rotational spectra, another one is the vibrational spectra. Then Raman spectra is also important, and the spectroscopic terms, LS coupling, all that is also important. But you will find that vibrational spectra and the rotational spectra will be involved in your Raman spectra part as well, okay, in different topics. So in case of rotational spectra, when you keep on studying about the rotational spectra, you get to know about absorption spectra there. So absorption spectra is a spectra which is having the spectral lines which are equidistant from each other. Okay, equidistant. And the absorption spectra is gonna have the lines present at 2b separation in terms of wave number, which is a constant separation. Means this should be equal to 2b. This, like the difference between this and this difference, not the value, this and this difference should be equal to 2b. This and this difference should be equal to 2b consecutive values. This and this value should be, difference between them should be 2b, 2 times the rotational constant, that b is rotational constant. Then next to separation should be equal to 2b. But what will happen in this case, if you will see the difference between 103 value and this given value is not same as the difference between 124 and 103. Okay, and is not same as the difference between this value and this value exactly. Means here in the given situation the difference is gonna keep on changing. But as we know, in case of absorption spectra, the separation will always remain same, and that is 2 times the b. So what should be done now? Since this time the separation is different, we will go for the average of the value. Means get the difference between first and second value, write that difference here. Second difference between the next two consecutive value, write that here. Third difference between the next two consecutive values, write that here. Fourth difference between the next two consecutive values, write that here. Divided by 4, and this will give you the average of the values, right? And just equate it with 2b and get the value of b, which is your rotational constant. Also, if you will go in more detail about the rotational spectra, you will have the idea about that b rotational constant value is h over 8 pi square. Okay, moment of inertia is, let me just tell you moment of inertia value, then we will write the b value from there, because we are just going to arrange the terms. Moment of inertia is equal to h over 8 pi square b. B is the rotational constant, and c you already know, 3 times 10 to the power 8. Okay, this is the moment of inertia. Now they have asked you to find the moment of inertia here. Okay, you have the information about b from here. You know h is a constant, pi is a constant, c is a constant, 8 is a constant. You are ready to get the answer. That's it, you got it. So how many points we discussed here? In case of absorption spectra, the separation between the two consecutive spectral lines, or separation, is a constant one, that is equal to 2b. But here, since the difference was not constant, we got for the average. We just found out the average. We equated with it with 2b, and we got the b value from there. Once we got b, we are ready to get moment of inertia, because rotational constant b is in terms of moment of inertia. So if you arrange, that will give you b value. So that's how you're getting I. Tell me what is the right answer now. You have all the information. Also, they have given you h cut over 2 pi c value. So you can see h cut is what? H over 2 pi. So I can write it as h cut over 4 to the 8. I will have the 2 pi c remaining, and I will have the 2b remaining. So it's so easy for you. H cut over 2 pi c value is given. Just put that value. 2b you will get from here. You don't even get to don't even need to find b. Just put the 2b here directly. Okay, and you got the answer. So calculation is quite easy, because they give you all the values there. Just average part you have to solve. Tell me what is the right answer after that. If you are not getting exactly same answer, you can tell me the approximate answer too. That's too okay. Approximate, or the closest one. Waiting for everyone to reply. If still somebody is not getting the steps, tell me, I can explain that again. Very good, Pravalika. Did you get power 48? Let's wait for others' reply too. Pravalika, just check your calculation till that point of time. Negative 44, and that's 144 in that. What is the 2b value you got? 2b, the average. Is it 20 points something? 20 point something? Average you have to get, not just one difference. And whatever 2b you got, h cut over 2 pi c value which is given in the question, which is 5.6 times 10 to the power negative 44 divided by 2b value. And see your calculation and the power of 10. Tell me the power of 10. Because if it is closest to 47, you will have other option correct. If it is closest to 48, you will have this option correct. What about others, guys? What about others? Waiting for others' answer. Yeah, that's correct, Sakshi. That's correct. Now you know this formula because your target is to get moment of inertia. So it is h cut over 2 pi c times 2b. So whatever 2b you got, plug it in here, and h cut over 2 pi c is given 5.6 times 10 to the power negative 44. Divided by 20 point, what you got, 62, right? So you are just gonna do this. This will give you moment of inertia. Tell me what you are gonna get then. See, option A is 1.1 times 10 to the power negative 48 kilogram meter square. Oh, guys, you also have to change centimeter inverse into meter inverse because your answer is in terms of meter. If somebody is not changing or converting it, your answer will be different. Can you see? The wave number is given in centimeter inverse and your answer is in meter square. So kilogram meter square, you have to convert it. And since you had that 2b here, and you know 1 meter 100 centimeter, so centimeter just simply, so 1 centimeter is equal to 1 over 100 meter, and that is centimeter inverse. So inverse you will have to take both sides. Done? Yeah, clear? And what is the power, Deepika? The 10 to the power, because 2.8 you have it at two places. Arrange it as 2.8 instead of keeping it as 0.28. And then just see the options, like which one, negative 47 power with 2.8 or negative 48 power with 2.8. Tell me, guys. See, if it will be just centimeter, I will take 1 over 100. If it is just centimeter inverse right now, what I have to take? The inverse of that value, that will be just 100. Right? Now, if I'm going to do this calculation, let me just tell you exactly. So, in that case, you will have, let me just even do it here. 10 to the power negative 46 I will get, right? 5.6 divided by 20.62 and 10 to the power negative 46. So then I'm going to write it as 5.6 divided by 20.62 and I'm getting 0.27, right? And when I will be Just arranging it as 2.7, I will have the 10 to the power negative 47. Just one more negative power will increase. So I am getting this. Now you will tell me, guys, are you even able to get the same? So my answer, which will be correct, is option B, which is 2.8 times 10 to the power negative 47. Sakshi and Pravalika and Deepika, check your calculation, and everybody, I have even done the calculation just now. You will also be checking it out and tell me, did you get it or no? Done? Just do this calculation in the calculator if you want to, or on your own. You will get approximate this value, arrange it in this form, you got this. Done? Very good, Deepika. Very good, Sakshi, that's great. Very good, Pravalika, that's great. Okay, very good, everyone. One last question and we will be ending this session then. Should I give you one more question? Just based on what we have learned right now, so that you will have a better idea about the concept, like, okay, this is important, and even you can expect this thing from here. Actually, I can have two questions from this section. Let's see whether we will take two or just one now. The first absorption spectrum of 12C 16O is at 3.842 centimeter inverse, while that of 13C 16O is at 3.673 centimeter inverse. The ratio of their moments of inertia is, options are 1.851. If you have the values of B and you think like, oh, I have to take the ratio, but I have to take the values of B. So remember, even if you are taking the ratio of 2B values, 2 will get cancelled out. So it doesn't matter. You can even take that ratio there. Okay, don't spend much time for the calculation if it can be done without spending time as well and in a correct way. So 1.046 and 1.038. Waiting for your reply now. See, again they are talking about absorption spectrum. That's why I've taken this question right now. So you know, absorption spectrum separation is always equal to 2B. So they have given you first absorption spectrum is at this separation, while the second one, this one is at this separation. So what is the ratio of moment of inertia? You know B, how B will be related to I, inversely proportional. So you have the 2B1 and 2B2 values. You can take their ratio, so you will get 2B1 divided by 2B2 is equal to I2 over I1, because inversely proportional. So B1 I2, B2 I1. Done. 2 and 2 will get cancelled out. I don't need to do that. I'm just directly gonna plug in this value there and this value there at place of 2B, and I will get the moment of inertia ratio. You can also see your all options are greater than 1. Means greater value will be divided by smaller value. So 3.842 divided by 3.673. Whatever ratio you are getting, that's your right answer. Very good, Sakshi. Very good, Deepika. That's correct. Very good, everyone. I hope you are gonna get it now. So absorption spectra concept is important, and I hope now you will not be making any mistake and you will easily be able to relate it. One more question is there from absorption spectra part. Okay, let's keep it this much because I think it will be clear with this part as well. Do you want to work on one more? Very good, Pravalika. Or should we keep it this much? And we will take approximately 15 minutes break in between, and then we will start the next session. Okay, so everybody can rest, relax, have something to eat and rest, and then we will start the next session. One more? Okay, let me just give you then. Achao. The far infrared rotational spectrum of a diatomic molecule shows equilibrium lines with spacing cm inverse. Main point I just missed. Here we are gonna have absorption spectrum. The position of the first Stokes line in the rotational Raman spectrum of this molecule is. Options are 20 centimeter inverse, 40 centimeter inverse, 60 centimeter inverse, 120 centimeter inverse. If you will get the answer, just mention it. If you will not get it, I'll help you then. Very good, Sakshi. That's great. Very good, Pravalika. That's great. You already mentioned it. So absorption spectrum, you already know the separation. And you have to get for the first Stokes line. Very good, Deepika. That's great. So absorption spectrum separation will be 2b. That will give you b is equal to 10. And first Stokes line is at 6b separation. So 6 times 10 is 60. We got the answer. So you can see how everything is related and how you can expect the questions to be there. Done. So let's keep it this much right now in this session, guys. After approximately 15 minutes, we will be starting the next session. That is on must to prepare concepts of condensed matter physics. And we will be taking the important questions and the concepts there. Very good, Manish. That's great. And that's correct too. Okay, guys. So as I have shown you the important slides in the starting of the session, which is going to be the first one regarding the iconic subscription. Even now the notes are available on the learning app. So if anybody wants to start their preparation under the guidance of top educators and don't want to miss the important courses in the classes by the top educators, so in upcoming days even so many new courses will be starting. Along with that, many new courses have recently started and going on. So you will be able to join them as well. If you missed any session, you will be able to check the recordings of the sessions too. So it will be helping you a lot to take your preparation to the next level. Even if any of your friends want to do the preparation under the guidance of top educators, you can share this information with them as well and let them know about the code too. That is Anjali A Live. So anybody who will be taking the subscription can use and apply the referral code that's Anjali A Live while taking the subscription. When you will use and apply this code, you will be able to get the discount in the total subscription amount. Same way regarding the plus subscription, we are having all the details mentioned here, that what are the benefits you will get. And when you take the iconic subscription, all the benefits which you are getting in plus, you get in the iconic subscription too. Same way here we are having details about light subscription, and the difference between the plus iconic and the light subscription have been shown here. So guys, if you want to take your preparation to the next level under the guidance of top educators and with important notes, you can take the subscription now. And use and apply the code Anjali A Live as mentioned here on the screen to grab the offer if any offer is going on and to get the discount in the total subscription amount. Thank you so much everyone for joining this session. I'll have one more session today here on Unacademy Live CSIR UGC Net, which we will start just in about 15 minutes. So rest, relax, and then